Hello viewers, in today's session we are going to discuss another very important and conceptual problem from differentiation, right? So here in this session we are going to find out the derivative of sine log x with the help of first principle, right? So here we have the function f of x is equal to sine of log x, and here log of x is the natural log, right? So we can also use this notation, that is sine ln x, but here we'll prefer this notation, that is log log of x, right? So the definition of derivative is given by this limit, that is f prime of x, that is d by dx of f of x is given by the limit, that is limit h tends to 0 f of x plus h minus f of x divided by h, right? So this definition of derivative in terms of limit is known as finding out the derivative using the first principle. So here the function is sine log of x. So what we will do, we'll write limit h tends to 0, and then we have f of x plus h. So f of x plus h can be obtained by replacing this x by x plus h. So we have sine of log of x plus h, and then we have f of x, that is sine of log of x, and in the denominator we have h. Now see, to simplify the numerator, that is the difference of two sine terms, will make use of an important identity from trigonometry, that is sine a minus sine b. So here our a is log of x plus h, and b is log x. So sine a minus sine b is equal to 2 times cosine a plus b over 2, and here we have sine of a minus b over 2, where a is a log of x plus h and b is log of x. So let us find a plus b over 2. So a plus b over 2 is given by a log of x plus h plus log of x divided by 2. So here log of x plus h plus log of x can be written as log of x times x plus h, and here we have 2, right? So here we have used the important property of log, that is log of m plus log of n is equal to log of product of m and n, right? Okay, so a plus b over 2 is given by this expression, and then we can find out a minus b over 2. So a minus b over 2 is given by a log of x plus h minus log of x divided by 2. Now here we can use this property of log, that is log m minus log n is given by log m over n. So here we have log of x plus h over x, right? And in the denominator we have half. So we can write half log, and we can distribute this x to x and h. So we have 1 plus h over x. So now we have a plus b over 2 and a minus b over 2. So now the derivative is given by a limit h tends to 0 and sine log x plus h minus sine log of x is given by sine a minus sine b divided by h. So now we have limit h tends to 0 and sine a minus sine b is 2 cos a plus b over 2 and sine a minus b over 2. So now we can, here we have h also. So this is limit h tends to 0. So now we have 2 over h and cos a plus b over 2. So a plus b over 2 is given by this term. So we have cos and then we have half of log of x times x plus h. So this is x square plus x times h, right? And this term, that is sine, and we have a minus b over 2. So a minus b over 2 is given by this term. So we have half and then we can write log of 1 plus h over x. So here we can write half log 1 plus h over x, right? So now our aim is to find out the value of this limit, right? Now here we have three terms. First one is 2 over h. Then we have cos half log x square plus xh. And then we have sine of half log 1 plus h over x. So here what we will do, we'll first write this expression like this. That is, we can now write limit h tends to 0. First we'll take this term, that is cos half, we have log, and then we have x square plus xh. So this is our first term. And then we can now write limit h tends to 0, and we can combine this term, that is 2 over h, with this sine term. So here we have sine, and then we can write half a log, and here we have 1 plus h over x, right? So now our aim is to find out the value of this limit and this limit. Now this limit is quite easy, because limit h tends to 0 cos half log x square plus xh. So here we can directly take h is equal to 0. So this term is 0, right? And we can assume this limit as L, and will separately solve this limit. So now the derivative f prime of x is given by limit. Here when we take h tends to 0, this term is 0. So we have cos half, and then we have log of x square, because this term is 0, and then multiplied with this limit, and we can call this limit as a limit L, and we'll solve it separately. So now here we have cos half, and log x square is 2 log x and times L, and here 2 and 2 get cancelled. So we are left with cos log of x multiplied with this limit, right? And now our aim is to find out the value of this limit L. So viewers, now it is very interesting to calculate the value of this limit, where we have a log term inside the sine term, right? So to find out the value of this limit, we'll make use of the method of substitution. And moreover, to get the value of this limit, we are going to use two standard results from limits. So the first one is limit theta tends to 0, sine theta over theta is equal to 1. And the other important result is limit theta tends to 0, e raised to theta minus 1 over theta is equal to 1. So these two results are going to play a vital role in finding out the value of this limit. So let us substitute here this term, that is a half log of 1 plus h over x as theta, right? So we can now write log 1 plus h over x is equal to 2 times theta. So multiplying theta with this 2. Now we can express this equation in the form of exponential equation by raising these two terms to the exponent of e. So we have e raised to log of 1 plus h over x is equal to e raised to 2 theta. So we can now write 1 plus h over x is equal to e raised to 2 theta, and h over x is equal to e raised to 2 theta minus 1. So h is now equal to x times e raised to 2 theta minus 1. So now let us take the limit h tends to 0. So here we are given that h is tending towards 0, right? So when h tends to 0, then theta tends to half log, and here we have 1 plus h over x. So when h tends to 0, then this term, that is h over x, it also tends to 0. So we can write when h tends to 0, it implies that h over x also tends to 0. So here h over x can be written as 0, and we are left with half log of 1, and log of 1 is 0. So this is half times 0, that is equal to 0. So we conclude that when h tends to 0, then theta tends to 0. So this is quite imperative to establish this result before moving further. That is, when h tends to 0, then theta tends to 0. Because when we establish that h tends to 0 implies theta tends to 0, then only we can utilize these results, right? So we have shown that when h tends to 0, theta tends to 0. So now this limit L can be written as the limit theta tends to 0. So now h tends to 0 can be replaced by theta tends to 0, and we have 2 over h. Now h can be replaced by this expression, that is x e raised to 2 theta minus 1, and we have sine of theta, because this term half log 1 plus h over x is equal to theta. So the overall result of this discussion is that this limit, which is in terms of h, is now reduced to this limit, right? And now we can easily evaluate this limit with the help of these two results. So now this limit L can be written as, we can take 2 over x outside this limit notation, because 2 over x is independent of theta. So we have 2 over x, and then we have limit theta tends to 0, sine theta over e raised to 2 theta minus 1. So we have 2 over x, limit theta tends to 0. Now see, we can express this expression as sine theta over theta, that is dividing sine theta by theta and then multiplying it by theta to compensate. And then we have e raised to 2 theta minus 1 over 2 theta, and then here also we can write 2 theta, right? So now we can have this theta and this theta get cancelled, this 2 and this 2 get cancelled, and we have limit theta tends to 0, sine theta over theta divided by limit theta tends to 0 e raised to 2 theta minus 1 over 2 theta, right? So when theta tends to 0, then 2 theta also tends to 0, right? Here we have 2 theta. So now this limit is equal to 1 due to this result, and this limit is also equal to 1 due to this result. So we have 1 over 1, and obviously here we have 1 over x. So here we have the term 1 over x. So here we have, we can write it like this: 1 over x times 1 over 1, because this limit is 1, this limit is 1, so we have 1 over x, right? So the value of this limit is equal to 1 over x. So now the derivative of f of x is given by f prime of x, and here we have cos of log of x, and here we have L, and L is equal to 1 over x, right? So the derivative of sine log of x is given by cosine log x divided by x. So now we can write d by dx of sine log x is equal to cos of log x divided by x, right? So this is how, by using the concept of first principle, we can find out the derivative of sine log x, and similarly we can find out the derivative of the function, that is cos of log x, and this is an exercise for the viewers to find out the derivative of cosine log x with the help of first principle, and the derivative of this function is given by minus sine log x divided by x.